In this lesson we're going to look at how to calculate the area below the x-axis. So we have a wee diagram at the side here, and we have our function y equals x squared minus 9, which cuts through the y-axis at 3 and negative 3, and we're looking to find this area here below the x-axis. So what we must remember is that when you integrate, then you're finding the area that's trapped between the x-axis and the equation or the parabola. This is done by creating rectangular strips and then adding all the strips up together. Now when you have a negative area like this, then the strips go down the way. We'll find out what happens through the example of what the area comes out to be. So let's have a look. We'll do the integration as normal. Integrate x squared minus 9 between 3 and negative 3. So we integrate the x squared, so that becomes a 3, and divide by 3 you're going to get a third x cubed, and integrating a constant just becomes 9x. So take away 9x here. Sub in the 3 to both parts, do a takeaway, and then sub in the negative 3 to both parts, which will come out looking like this. So we've got 3 cubed, which is 27, third that you get 9, so we're going to have 9 take away 27 in this first bracket, which is negative 18, take away, and in this part here we've got negative 3 cubed, which is negative 27, third that you get negative 9, and then we're going to get plus 27, so that's going to give us 18, negative 9 plus 27. So negative 18 take away 18 gives us negative 36 units squared. When you're working out an area, it's impossible to get a negative area. So what we do in this case is we ignore the negative sign and we rewrite the area as 36 units squared. Don't just write an equals underneath this, make a new statement and say that the area is 36 units squared. Because the calculation is going down the way here, we will have a negative area because your length, if you like, will be across the way, but your breadth going down the way, or sorry, your breadth will be across the way, but your length going down the way by negative value, so it will create a negative area here. But just change it to a positive area. That's how you calculate the area under the x-axis. What about this example here, areas above and below the x-axis? Well, if we were to integrate y equals x squared as normal between 6 and negative 6, something strange happens here. So let's have a look. Integrating a half x, so that's x to the power 1, so add 1 to the power, you're going to get a 2. And if you do a half divided by 2, you're going to get a quarter. So a quarter x squared between 6 and minus 6. Sub in the 6, and then take away and then the negative 6. So we're going to get a quarter of 6 squared, which is a quarter of 36, which is 9. And a quarter of negative 6 squared, so that's a quarter of 36, which is 9. 0 units squared. This doesn't make any sense because you can see that the triangle here and the triangle here are more than 0 if you're thinking about area. So we have to do something else, and I'm going to show you how to do that in the next lesson. The reason it comes to 0 here is because if you think of that, that will create a positive area. That area is exactly the same, and that will create a negative one from exactly the last slide we looked at. And these will cancel each other out to give you 0. So we can't integrate above and below between 6 and negative 6. It doesn't work.